Okay, so we're going to start with how to graph an absolute value function. So here we have y is equal to negative 2 times the absolute value of x plus 3 minus 4. So we are going to start by figuring out what our vertex is. The vertex is going to be given to us from our function. It is going to be written as a point, x comma y. So to figure out what our vertex, or what our x value of our vertex, we look at the inside of the absolute value, and we take the opposite of that number. So since it's a plus 3, the x value of my vertex would be a negative 3. The y value of the vertex is whatever number's on the outside, so negative 4. And we would go ahead and plot our vertex. So we'll go to negative 3, negative 4, and plot a point. Okay, next we are going to figure out what the next few points are by looking at our slope. The slope of the line is going to be given to us by the number that's in front of our absolute value, the compression or the stretch. So here it has a negative symbol. That means it's going to be reflected. So it's going to be negative, going down from left to right. It's a negative 2. So what I'm going to do is I'm going to write that as a fraction. We need to put it over 1 so that we have a rise over a run. So starting from the point that I plotted from my vertex, I'm going to go down 2 to the right 1, plot a point. And it doesn't look like I have any more room on my graph here, so I'm going to go ahead and stop there. And then I look at where my axis of symmetry is. Remember, the axis of symmetry is the line that goes through the vertex. It's x equals wherever it crosses the x-axis, so it's going to be x equals negative 3. So I'm just going to draw my axis of symmetry here. And any points that I have on the right side of my axis of symmetry, I'm going to reflect over the axis of symmetry. So this point here, it's one space away from the axis of symmetry to the right. So I'm going to move one space to the left and plot a point. Whoa, that's way too big. Something smaller. There we go. And after I do that, I draw my line in and I'm done. Make sure your line extends to the end of the graph and put an arrow on the end. And that's it. Okay, next what we're going to look at is how to graph an inequality, a linear inequality. So here we have y plus 2 is less than negative 3x plus 6. The first thing you need to do is make sure it's in slope-intercept form. So remember, that's where we have y equals mx plus b. The y needs to be by itself. So right now I need to get rid of this plus 2. So I'm going to subtract 2 from both sides. And I end up with y is less than negative 3x plus 4. And then I can go ahead and graph. So the first thing that I graph is the y-intercept. The y-intercept is plus 4, so I'm going to go to 4 on my y-axis and plot a point. Okay, next I'm going to use my slope to figure out what my next few points are. So the slope here is negative 3. We need to write the slope as a rise over a run, so I'm going to go take my negative 3 and put it over 1. So that means I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, plotting points as I go. So starting from my y-intercept, down 3 spaces to the right 1, I'd plot a point right there. Okay, and then again, down 3 spaces to the right 1, plot my point. Okay, and then I would continue to do that. So down 3 to the right 1, plot another point. And after I do that, I go ahead and draw my line in. So for inequalities, I have to determine if it's going to be a dashed or a solid line. And we can tell by looking at the inequality. So the inequality is a less than symbol. It doesn't have an equal sign under it. So that means this will be a dashed line. Anytime we have a less than or a greater than symbol, our line is going to be dashed, like that. If we have a less than or equal to or greater than or equal to, that's when we have a solid line. Okay, so since we have that greater or less than symbol, that means we're going to go ahead and just draw in a dashed line. Hopefully yours will look straighter than mine does. Okay, and make sure it extends all the way to both ends of the graph and that you put arrows on the end. And then the last thing that we need to do is our shading. So for inequalities, we shade either one side of our plane or the other. So this one has a less than symbol as my inequality. Remember, less than means we shade below the line. If it were a greater than symbol, that's when we shade above the line. There's another way to do that as well if we wanted to use a test point. Easiest point to use as a test point is 0, 0. If we take that and we plug it in. So I'm going to plug in 0, 0. 0 is less than -3 times 0 plus 4. If I simplify that, I get 0 is less than 0 plus 4. Okay, is 0 less than 0 plus 4? Yes, it is, because this ends up being 0 is less than 4. That is a true statement, so that means that 0, 0 is going to be true. It makes the inequality true. So since that makes the inequality true, that's the side that I shade. If it made the inequality false, so say I ended up with something like 0 is less than -1, or something like that, I would shade the other side of the plane then. Okay? So it's two different ways to figure out what side you shade. Either looking at the inequality or using a test point. Okay, so like I said though, the inequality is a less than, so you shade below the line. So under the line, it's going to be to the left of it here. So I'm just going to shade that in. And that's it. Okay, so next we're going to look at how to graph absolute value inequalities. We're going to do basically the same thing we had to do for linear inequalities. We need to draw our line, decide if it's dashed or solid, and then shade either above or below the line. So for this one, I'm going to start by figuring out what my vertex is. To draw the line for an absolute value, we start with the vertex. So our vertex for this, remember we do opposite of what's inside, keep the same number on the outside. So my vertex is going to be 2, 1. And I would go to +2, +1, and plot a point. Okay, then I'm going to use the number that's in front of my absolute value to find my next point. So for this one, the stretch of the compression is actually just a 1. And then that negative symbol tells us that we've reflected it. So we're going to be going downward. Okay, that's the number that's in front of my absolute value. So I am going to put that over 1. So I'm going to be going down 1 to the left, or I'm sorry, to the right 1, down 1 to the right 1, down 1 to the right 1, and so on. So down 1 to the right 1, plot a point, down 1 to the right 1, plot a point. So I'll end up with something that looks like this. Then I just need to take each of those points and reflect it over my axis of symmetry. So this point is one space to the right of the axis of symmetry. I'll go one space to the left, plot my point. Whoa. Not what I meant to do. There we go. Okay, and the second point is 2 spaces away from the axis of symmetry, so I'll go 2 spaces to the left, plot it. Okay, and then I will continue to do that for the other points. Okay, now I have that nice V shape, and all I need to do now is draw my line in. So determine if it's going to be solid or dashed by looking at the inequality. It's a greater than or equal to, so that will be a solid line. And make sure it extends all the way to the end of your graph. And you put your line, your arrow at the end. Okay, and then the last thing I need to do for these types of problems, when it's an inequality, I have to shade either above or below the line. So since it's a greater than symbol means I shade above. So I would take everything above, shade in the line. There we go. Okay, second way to do that, remember, is to use a test point. So if I wanted to, I could use 0, 0, which is it's above the line. So I'm going to test 0, 0. And I test it by plugging it into the inequality. So 0 is greater than or equal to 0 minus 2 plus 1. Okay, so I end up with 0 is greater than or equal to, just continuing to simplify it. Okay, in the most simplified form, I end up with 0 is greater than or equal to, oops. I don't think I can actually write the equal to symbol. -1. So this is a true statement, so since it ends up being a true statement, that means that I would shade in the side that contains 0, 0, which is what I did. Okay, so that's the second way to do it. Either using a test point to determine if that side makes the inequality true, or just looking at the inequality. If it's a greater than symbol, we shade above. If it were a less than, we would shade below. Okay, so next we're going to look at writing the absolute value inequality function when I'm given the graph. So for this one, I start by looking at where my vertex is. So my vertex is at this point, which is at 1, -4. And then I need to look at what my compression or my stretch would be. So I do that by looking at the slope, starting from the vertex and going to the right. So it looks like I had to go up 1, 2 over 1, up 1, 2 over 1. So it looks like I'm going up 2 and over 1 each time. So 2 over 1, which is equal to 2. So that's my compression or stretch. Okay. And then I just need to plug those three numbers in. So remember, the general form is y is equal to a times the absolute value of x minus h plus k. So I'm plugging in a, h, and k. So I plugged the stretch in for a. So y is equal to 2. Absolute value of x minus h, and h is just whatever the x value of your vertex is. So my x value of my vertex is 1. So x minus 1. And then on the outside, the -4. And that is all I had to do. I'm done. Okay, and the last type of problem we're going to look at is absolute value inequalities, writing the inequality from the graph. So just like the previous one with the equations, inequalities start out the same way. Zoe, stop it. Stop. Okay, our vertex is going to be at 2, 0. So I write my vertex. And then I look at the compression or the stretch. So starting from the vertex, going to the right, it looks like I'm going up 3 and over 2, up 3 and over 2. Okay, so my stretch is 3 over 2. And then the last thing I need to do is plug it in. Find the inequality. So looking at this one, I've shaded above the line, so it's going to be a greater than. And since this is a solid line, it's going to be a greater than or equal to. Okay, if it were a dashed line, we would just leave it as a greater than symbol. When it's solid, we put the equal sign under it. So this will be my inequality. And then I just need to plug it in. So remember the form, y is equal to a times the absolute value of x minus h plus k. Except instead of an equal sign, I'm going to be using this inequality. So y is greater than or equal to 3 over 2, absolute value of x minus 2, plus 0. And then if we can simplify, we will. The plus 0 on the outside is not necessary when we add 0 to this, the 3 over 2, absolute value of x minus 2. If we add 0 to that, it doesn't change anything about it, so we're going to get rid of that 0. We can drop it. So this will be our final answer. Okay, and that is the end. If you are enjoying this video, please like it on Edmodo so that way I know people are actually watching these. And please make sure you look for the review video that will be up for the test on Thursday and Friday.